guys, this is a video going over the answers for worksheet 5. So let's go ahead and take a look at number 1. There are 6 sig figs because trapped zeros are all significant. Trapped zeros are zeros between non-zero digits, so they're all significant. Then we look down over here. These are leading zeros. They're not significant, so therefore 4 significant figures. Remember, there's no such rule as leading zeros with a decimal are significant. That rule is only for trailing zeros. Moving up here, we've got these are trailing zeros, and they're not significant unless there's a decimal present. And since there's no decimal, not significant. And then for scientific notation, you always look at the measurement, which is up here in the front. Remember, these are just places, and they're not significant. So therefore, the measurement in scientific notation holds all the significant digits. So there's 2. Okay, now let's look at our next part right here, and we're adding in part A. I went ahead and added all these, and this is my pre-rounded answer. I should have written meters right there. And so I rounded it to the hundredths place. Remember, the rule is when you add, you go to the least amount of places. So we look at this measurement, hundredths, thousandths, but you're only as good as your weakest link. Your weakest measurement has, right, only 2 places after the decimal. So my answer has 2 places after the decimal. And don't forget, a meter plus a meter plus a meter is a meter. Okay, in this instance over here, we're subtracting. Did you remember to subtract? If your number is very different than mine, you might have accidentally added. So when I subtract, I get a negative number, and I know you're thinking a negative meter. Yes, that's funky. You would never get a negative meter. But for the sake of just mathematics, I did tack on that negative, though really there's no such thing as a negative meter. We do have negative temperatures. So when I subtract, remember, same thing, same rule. You go to the least amount of places. So I've got 4 places after the decimal, but this one only has 3, so your answer can only have 1, 2, 3 places after the decimal. Is that 0 significant? It is, because a trailing 0 is significant as long as there's a decimal somewhere in the number. And a meter minus a meter is still a meter. Check your units, please. Okay, let's move on now to the next rule, and that is multiplying and dividing. So this first example, I'm multiplying these 3 measurements. And if you notice here on the top, I always like to write how many sig figs there are. I recommend you do that. So there's 2 sig figs here. Remember, a leading 0 is not significant. 4 sig figs here, trailing 0 is significant with a decimal. And 2 sig figs here, trailing 0 is not significant because there's no decimal. So in this instance now, for multiplication, it's a different rule. It's not the same as the rule for adding and subtracting. Now we want to count total significant figures. Has nothing to do with the decimal places behind the number. So 2 is the smallest number of significant figures, so I round my answer to 2 sig figs. So 5, 5, 6. So 1, 2 sig figs, but I look next door. If that's 5 or higher, I have to round up. So 556 rounds up to 560. I need that 0 because it holds the magnitude of the number. This is a number in the hundreds place. So, but remember, this is not significant. It's a trailing 0 with no decimal. So therefore, this person, right, when they multiply these different measurements, in the end, this is the part where they're certain about. That's their estimation, and that's just a placeholder 0 because it mimics this measurement, which was the weakest. Okay, so now let's move on to this division one. Remember, this is a division sign, so if your number is different, you might have accidentally multiplied them. 3 sig figs in this one, only 1 sig fig here. Remember, leading zeros are not significant. Doesn't matter about a decimal or not, there's no such rule. A leading 0 is not significant. So 4,820, I'm going to round to 1 sig fig, but you have to look at the next door neighbor. If that's a 5 or higher, this rounds up. So an 8 is 5 or higher, so this rounds up to 5,000. And all I'm going to do with my units is divide them by each other. So if you're dividing numbers, you divide the units. They don't cancel out, so it's still a gram over a milliliter, which is a unit for density. It's a good thing to kind of write down on the side if you did not remember that from previous science classes about density's unit. Okay. In these instances, they're just asking you to round to 3 sig figs, but remember, anytime you're going to round or chop something off, you have to see if the neighbor is 5 or higher to round up. So here's 3 sig figs. Look at the neighbor, and it's a 5 or higher, so this rounds up to 708 liters. Don't forget the unit. Same thing here, 1, 2, 3 sig figs, and the neighbor 0, so this stays as 2,300, but there's an issue with this one. I still need 3 significant figures. And so in order to make that last zero significant, I have to put this in scientific notation. So I use scientific notation in this instance in order to make one of the zeros significant and still show that this number has more places in the notation seen here. Okay, I would put a star next to this one. Might be good to ask me this in class if that did not make sense to you. Okay, next, this next one over here. Leading zeros are not significant, so therefore 1, 2, 3, sig figs. So I don't need that zero. I need to chop it off. And if I included it, remember a trailing zero would have been significant, so that would have been 4 sig figs, and we don't want 4 sig figs. We only want 3, so I get rid of that. Can I get rid of these zeros? No, because then I lose the magnitude of the number. Now I have a little note for you written down here. If you remember, one of our videos was scientific notation. This is a really small number with a lot of zeros. So we should put numbers that are in the thousands or thousandths in scientific notation. So this one would go into scientific notation just for the scientific notation rule. This one went into scientific notation for Sig Fig reasons. Okay, again, good ones to put little stars next to and ask in class if you still have questions. Moving on, they just want us to put these into correct scientific notation. If there's 4 sig figs, I still need 4 sig figs, so I move the decimal over to the left. Exponent is positive, unit goes to the back end. Over here, I'm going in the opposite direction, goes to the right, so my exponent's negative. Remember, this is a small number, so therefore a -6 denotes the smallness of this. Okay, and so therefore I moved it over 6 places, and I still retained 3 sig figs. There's no reason why, if I put things in and out of scientific notation, that I should lose or gain sig figs. Unit goes at the back end. Okay, looking at these next two, this really kind of gets a little more heavy into math, so it really depends how much you remember from your algebra class, which is the prereq for this class, for reasons like this right here. So this is something that you're required to kind of walk in chemistry knowing how to do. So this should be a review right here. If it's not, please make sure that you brush up on this. If you're multiplying numbers together that are in scientific notation, then their exponents get added. I made a little note, add that to your notebook, please. So I multiplied the first measurements, 1.54, by 3.5. Since I'm multiplying, there's only 2 sig figs in 3.5. So round your multiplied measurement to 2 sig figs, so 5.4. Then I took the exponents 58 and 60 and I added them up, and there it is. We don't do sig figs in the exponents because exponents are not measurements, they're just places, right? Placeholder zeros. Okay, in this next example, I'm dividing. Make sure that you divide it. If you have a very different number than me, you probably accidentally multiplied, because I did that accidentally the first time myself. Here's the measurement in the front. Multiply them both. But this one's tricky. So when I multiply these two, I get this number, 0.9495. That's not in correct scientific notation. If you remember from our scientific notation notes, scientific notation has the decimal behind the first non-zero digit. Okay, so we'll talk about that in just 1 second. Let's see what I did with the exponents. I took 34 and I subtracted it from 23. Remember, when you divide, exponents now get subtracted. So here are my 2 notes. When you're multiplying, exponents get added. When you're dividing, exponents get subtracted. Okay, so I subtracted my exponents and I get 11. But remember, this number is not in proper scientific notation. You will get this wrong if you leave it in this. This is called, I don't know, your made-up notation. So there's no such notation like this. So I have to move the decimal over 1 place. And when I move it 1 place to the right, I remove one of the places from the exponent. Because remember, this shows me how many places I have. So I'm moving it to the right, so my exponent goes down 1. So now it's 9.5 times 10 to the 10th. Why did it go to 9.5? Remember, I'm dividing, so I go to the least number of sig figs. 7.9 only has 2 sig figs. 9.5 has 2 sig figs. Okay, moving on down here, number 6. All I'm doing is taking this number and putting it in scientific notation. Remember, taking numbers in and out of scientific notation, I should still have the same number of sig figs. So I move my decimal over to the left, times 10 to the 5th to reflect places. 1, 2, 3, 4, 5 places. That's what that is. 2 sig figs, 2 sig figs. Same thing here, I'm moving to the right, so it's negative for a small number. 3 sig figs, 3 sig figs. Don't forget the unit goes at the end. Remember, you will you will have a deduction in points for graded worksheets if you forget your units. Our numbers are measurements, so whenever you see a unit, you know you have a measurement and you have to keep that. Okay? There are 5 sig figs here. Remember, trap zeros are significant and a trailing zero is significant as long as there's a decimal anywhere in the number. Leading zeros are not significant, so there's only 3 sig figs here. These are just counted. This is me saying 5 digits are significant. 3 digits are significant. Since they're not measurements, they don't have units. Okay, over in this instance, we're going to add again here. And remember, now with adding and subtracting, it's a different Sig Fig rule. It's the least amount of places behind the decimal. 2 places behind the decimal is less than 3, so my answer needs 2 places. But remember, if I'm going to chop off, see the dotted line? I got to look at the neighbor. If the neighbor's 5 or higher, this goes up. So this is 1.68 kilometers. In subtracting, it's the same rule as adding, least amount of places behind the decimal, so there's 1 place, so therefore only 1 place behind the decimal. Look at the neighbor, 5 or higher, this has to round up. So there it is, unit at the back end. Okay, let's keep going down here. Now in this instance, I'm multiplying and dividing. In this one, I'm multiplying, so now we're at the multiplication Sig Fig rule, and that is not places behind the decimal. Don't get confused, that's total counted Sig Figs. So this number has 1, 2, 3, 4 sig figs. This number has 1, 2, 3, 4, 5. 4 is less. You're only as good as your weakest link. So here's my number, pre-rounded. 1, 2, 3, 4. But if I chop this off and get rid of the 8, right, then I'm going to have a number that's no longer in the 10,000s, so I lost the magnitude. So what do? I make it a placeholder 0. So this rounds up to 21,510 meters squared. A meter times a meter is a meter squared. Okay, again, that's something you should have learned in algebra, which, like we said earlier, is your prereq into this class. So take down these notes. You could have also put this in scientific notation. All right, here is B. I'm still multiplying in this instance, 2 sig figs here, 3 sig figs here, but now I have scientific notation, so you multiply the front together. And then you take the exponents, and remember when you're multiplying, you add them. So that became -8 actually, and I moved it over, so sorry, that should have been -8, my error. And I moved the decimal over. Remember, you have to go to the left one, so this turns into -7, so that's correct. And correct notation would be 1.4 times 10 to the -7. You can't have a number like 14. Scientific notation can't be greater than 10 for the measurement in the front, okay? All right, and so a kilometer times a kilometer is a kilometer squared. So again, my only error, I apologize, is this right here. It should be -8, but then when I move the decimal over, I correct the place there. Okay, then, I think that was the last one. So that's it.